Hi, mathletes. We are continuing our discussion on linear function pattern recognition, focusing today on filling in the blanks for our table. So our objective is I can find missing values in a table or extend a table in either direction by using rates of change. We're going to start by looking at our opener and looking at these two tables. So we have table A and table B. And before we fill in the blanks, we're going to name two things that are the same about these two tables and two things that are different about these two tables. So in looking at things that are the same from these tables, you might have recognized that there are some values that are the same in these tables that I'm highlighting here in yellow. So that might be something that you write down, that there are some things that are the same. You might also just note that they are both XY tables. Or you might have noticed something about their rate of change. So lots of things you could have there. Some things that are different, you might say that table B has blank spaces. You might note that table A has more values. It goes to 16, whereas the X values in table B only go to 8 that we can see. Before we talk about the big idea here, we want to talk about what is the values that are missing from table B. Can we figure that out? What are we looking at? Remember, with tables, the best place to start generally is to do your change in X and change in Y. So take a moment to do that right now. You can see that our change in X from what is showing is +2 for both of them. So even though we're alternating spaces, I just did what was labeled. So we have +2 and +2 for change in X, and then +10 or increasing by 10 for the change in Y. I think we mentioned this briefly, but we know that the rate of change is the same for both of these tables for what we're seeing. So that's something that we could add. How can I use this information to predict what's in our blank sections? So filling in the blanks. Sort of intuitively, if I've gone by 2 here, that means I'm missing one space here. So you could go through and identify that it goes 2, 3, 4, 5, 6, 7, 8. So that means that our change between every space is +1 here. From 3 to 4 is +1, and it would be +1 all down the table. Looking at our change in Y, what do you think is going on there? If we're going 10, every other space is going 10. Hopefully, we realize that 2 5s, 5 plus 5 and plus 5, would make our 10. And so 16 plus 5 is 21. 21 plus 5 is 26. And you can complete this for the rest of the table. Hopefully your table looks like mine, where you can see that your Y values, if you go by every single row in this table, are increasing by 5, where every 2 are increasing by 10. And so I want to take a look at what would these tables look like if we were to graph them, because I think it gives some insights and will help us define what I'm thinking of as my big idea for this. So I pulled up here a browser that shows a Desmos Calculator where I have put in the table of values. Table A is in green, and I have that showing all of the points there. And so you can see that it is a line. You can see that it has a constant rate of change as it goes up. That's what makes the table of values, when they're plotted, fall into a line. And then I can add here, if I add those colors, so now it's plotting table B in red, and so it's just fewer of those same points, but it's the exact same points. And then if I scroll down and I include the missing points, the points that we missed, I can add in, and it's showing those in between points in that smaller section. So we're really all talking about the same line, we're just looking at different parts of it. So the big idea that I was thinking about when I put these two tables together is that table A and table B are really represent the same linear function.